All right, moving along. So we solve for the acceleration. Now we need to figure out the next part, which is how long does it take the train to stop? And so let's take a look at how we do that. So we are going to solve for the time. So in order to do this, we need to look at the formula for acceleration. Acceleration is equal to final velocity minus the initial velocity divided by delta t. So let's just plug in our values. So what is the acceleration? So we solved it in the previous video. It is 0.7, remember it's negative, meters per second squared is equal to, now let's think about this. What is the final velocity in this scenario? The final velocity is 0 because we're saying how long does it take the train to stop. So the final velocity is 0 and we are going to subtract the initial velocity. So at the time the engineer stepped on the brake, what was the velocity? So we actually converted it. So it was 80 kilometers per hour. When we did our conversion, it came out to be 22.2 meters per second. So let's plug that in. 22.2 meters per second divided by delta t. All right, so now all we have to do is multiply delta t. That cancels out delta t. And remember, whatever we do to one side of the equation, we have to do to the other side. So we multiply by delta t. And then we have to get delta t by itself. We are going to divide our acceleration. Once again, that cancels out. And so what we have here is delta t is equal to negative 22.2 meters per second divided by negative, oh, I forgot the negative there, negative 0.7 meters per second squared. This is really important because notice how both the numerator and the denominator is negative. So what happens is that cancels out and we're left with a positive value. This is important because if you have a negative value for time, that means you did something wrong. Time is a scalar quantity. It only can be positive. So make sure you're aware of that. Now notice something else as well. I'm going to show you a shortcut. So whenever we are solving for the denominator, we can actually just swap out. And let me kind of show you what I mean by that. So the delta t over here, if we're solving for delta t and we have the acceleration, we could actually just switch these out. So delta t goes over here where the a is, and the acceleration becomes the denominator. So the shortcut, notice down here, right? I'm just going to rewrite this just so that we're clear. So let's write it out again. So negative 0.7 meters per second squared is equal to 0 minus 22.2 meters per second divided by delta t. So notice this, I can just swap these two. So what I'm left with is delta t is equal to, we just get rid of the 0, 0 minus 22, negative 22.2 meters per second divided by negative 0.7 meters per second squared. You see that? So whenever we're solving for the denominator, we can just swap it out with the numerator on the other side of the equal sign. So let's just solve for it. So negative 22.2 meters per second divided by negative 0.7 meters per second squared. What is delta t? How long did it take the train to stop? So delta t is equal to 31.7 seconds. So it took 31.7 seconds for the train to stop. And that is step 4.